Chapter 2, Force and Pressure. Learning objectives are scalar quantities and vector quantities, uniform motion and non-uniform motion, mass and weight, last one spring balance. First we are going to discuss about scalar quantities, those physical quantities which have only magnitude but no direction are called scalar quantities. Examples: mass, length, time, density and speed. Next we are going to discuss about distance and displacement. What is distance? The actual length covered by a moving body is called a distance. That is very important. The actual length covered by a moving body is called a distance. So what is displacement? The shortest possible distance covered by a body between its initial and final position is called displacement, or easily you can understand that is the distance means the actual length. Displacement means two initial positions, initial and final positions. It is called displacement. Further, yeah, vector quantities, those physical quantities which have both magnitude and direction. See, recall the scalar quantity. The scalar quantities only having magnitude but no direction, but vector quantities having both magnitude as well as direction. So these are called vector quantities. Examples: velocity, displacement, acceleration, moment, weight, etc. Displacement. Look at this picture. Suppose a boy riding a bicycle want to go to the position of C. It is the straight way 5 meter. Suppose another one way A to B home and B to C after reaching the tree. So two ways can move. The displacement is always the straight line path between the initial and the final point. It is very important. That displacement means initial and the final point of the motion. While stating the displacement, it is essential to state the direction of the motion. Distance is the total length irrespective of its direction. It is important. Okay, the one is 5 meter, another one is 4 meter plus 3 meter, 7 meter. So which is greater? 7. So straight line means 5 meter. If you want to go to another one way means 7 meter. So the SI unit of both the distance and the displacement is meter. Distance and displacement. Further we will discuss. Suppose one example, the couples moving in the straight way 30 meter and another one person athlete moving another one way, that is the 40 meter. Okay, so from this picture we will easily understand the distance means 30 meter, both are same, that is it may be athlete or couples reaching the point 30 meter, but the straight line is the distance. The another way is displacement. 40 meter is the displacement, that is the distance and the displacement. Speed, already we know that in previous lessons. The speed formula, distance, that speed is equal to distance traveled by time taken. Okay, numerical problem. A train having speed of 75 km per hour takes 6 hours to travel from Delhi to Ahmedabad. Calculate the distance between these two places. Okay, so what are the values they given? We should note down. That is speed 75 km. Time already they given 6 hours. What we want to find out? Distance question mark. Okay, this is the common formula. Speed is equal to distance traveled by time taken. But we need only distance, so we change this formula so that the speed left side is there, time it is down, it is go to upside, that is cross multiplication. Speed into time we will get distance. So substitute this value: speed 75 km per hour into time 6 hour. R will be cancelled, so the remaining value multiply and we will get 450 kilometer is equal to distance. Another one numerical problem. A car is running at a speed of 60 kilometer per hour. How much time will it take to cover a distance of 270 kilometer? So these are the values we should note down. Then write the formula. Speed is equal to distance traveled by time taken. So what we need, how much time? So arrange this formula. So time go to upside and the speed go to downside. After we will substitute these values, that is distance 270 kilometer and the speed 60 kilometer per hour. Kilometer will be cancelled, the remaining 0 cancelled, the remaining value is 4.5 r. That is, when we divide these values, it is the final answer. And another one numerical problem. An ant covers 1 meter distance is 10 seconds. What is the speed of an ant in centimeter per second? So we want to change in centimeter per second. So this is the common formula. Already we know well, 1 meter is equal to 100 centimeter. So a distance, what is the distance? 1 meter. Okay. What is time? 10 seconds. Okay. So 1 meter. So 1 meter we will write 10, that is the 100 centimeter. 100 centimeter. Substitute these values and we will cross the 0 and 110 is 10. So the final answer 10 centimeter per second. Again I repeat, 10 centimeter per second. The fourth one is a car traveling at a speed of 45 kilometer per hour takes to reach its destination. What distance has the car traveled? So write the values. What are the values they given? Speed 45 kilometer per hour, time is equal to 20 minutes. See here, time is equal to 20 minutes, so we want to change into r. So when we divide with the 60, we will change into r. So the answer is 1 by 3 divided by 1 by 3 into r. So what is the formula? Speed is equal to distance traveled by time taken. Okay, so what we want to find out? Distance. So change this formula. Already we know this formula. Speed into time is equal to distance. Speed, what is speed value? 45 kilometer per hour into time 1 by 3 r. R will be cancelled and the remaining values, and when we divide these two values, finally we will get 15 kilometer is equal to distance. The another one sum, the speed of a racing car is 60 meter per second. What will this speed be in kilometer per hour? So one value they given meter per second, we want to change it to kilometer per hour. Already we known well, 1 meter is equal to 1 by 1000 kilometer, 1 second is equal to 1 by 3600 r. So 60 meter per second is equal to 60 into 1 by 1000 kilometer and whole divided by 1 by 3600 r. So multiply these values, 160 into 60 and divided by 1000 whole divided by, so divided by, we want to change into multiplication because we will change the reciprocal, and 3600 upside and 1 goes to downside. Okay, and finally we will multiply this value, we will get 260 kilometer per hour. Okay, and the next topic, unit of speed. It is very important. More 1 marks will become in this topic. The standard unit of distance is meter. The standard unit of time is second. The standard unit of speed is meter per second. The small values of speed we will express it by centimeter per second. For example, snail will be moving very slowly, so we will measure it by centimeter per second. And the large speed we will express it by kilometer per hour. All the vehicle, all the two-wheeler, four-wheeler, we will express it by in this value. And the very large speed we will express it by kilometer per second. Example of rocket, space rocket, etc. Next, uniform motion and non-uniform motion. The uniform motion, an object moving along a straight line path, the remains will be constant, that is the speed will be constant. That is called uniform motion. Example of, see here, the car moving each time A, B, C, D, each position it will take the time of 2 seconds. So that this is one example of uniform motion. And non-uniform motion, An object moving along a straight line is said to have non-uniform motion if its speed keeps changing. It is very important. See here, uniform motion, speed constant, but non-uniform motion, speed changing. That is the difference. So it does not remains constant. So this is called a non-uniform motion. So this is the graph we will understand. This is the non-uniform motion. Okay, and a distance time graph for uniform motion. It is very easy. From the graph we will understand, when we see the motion of an object, we will understand what is the motion. So when an object moving in straight line, we will know that is called uniform motion. Another one example, when two objects moving at the same time, we will understand which object moving faster, which object moving slower. So this is one example of uniform motion. And next we are going to discuss about non-uniform motion. The non-uniform motion, when an object moves with a non-uniform speed or changing speed, it travels unequal distance in equal interval of time. Time is equal but unequal distance. When we see the graph, the object moves in different way. So this is curved path. So this is an example of non-uniform motion. And the next one is stationary, that is zero speed. When you see this graph, zero x-axis and y-axis, always you want to take the time in downside, distance in upside. So when an object is rested, we will say that is called zero speed. Suppose they are asking the diagram, you want to note down all these parts, label the parts, yes or no? Horizontal line, zero speed, distance, time, arrow mark, ox, oy, all the one you want to mark. Yes, right. And the graph, from the graph we should note down the motion of an object. See, 0 0 0 0 1 1 1 1. Okay, here 2 2, this point B, 3 3, this point C, 4 4, D, 5 5, E. So equal distance. Okay, 0 to 1, 0 to 1, at 0 to 2, 0 to 2, equal distance in equal interval of time. So this is an example of uniform motion. Further two graphs you can see in your school app. Next one is mass. The mass of your body is the quantity of matter or material contained in it. Mass is a scalar quantity. Already we know well. The SI unit of mass is kilogram. Example, 5 kilogram. Suppose you will go to the market. You want to buy something, the vegetables. So you will get by the kilogram. 1 kg potato and 1 kg tomato, like this way, right? Weight. So now weight, the weight of an object is the force with which it is attracted towards the center of the earth. The SI unit of weight is Newton. Example of suppose we want to find out our weight by using weighing machine. This is an example of weight. Yes, and some more points about the weight. Force is equal to mass into G. The G means gravity, acceleration due to gravity. Further force we will add a W. W means weight. W is equal to M into G. Finally, weight is equal to 9.8 Newton. Spring balance. Yeah, spring balance measures the weight of your body by opposing the force of gravity with the force of an extended spring. So this is an example of spring balance. The downside hook is that suppose any weight we want to attach it, we will find out what is the force acting and what is the weight of an object. That is spring balance. So here you will notice that suppose any one of the weight will be attached to it, the spring goes to downside. That means expansion. Expansion means virivadiradu. Okay, so the spring will be expanded. We will note down how much force will be acting. So here 150 Newton will be acting. Okay. In this way, the spring balance will be acting. Hooke's law: the amount an elastic body stretches out of shape is directly proportional to force acting on it. So இதில் என்ன சொல்றாங்க அப்படின்னாக்கா, இந்த ஸ்ப்ரிங் எக்ஸ்பேண்ட் ஆகுது பார்த்தீங்களா, the spring will be expanded. It is directly proportional to the force acting on it. எவ்வளோ force act ஆகுது அப்படிங்கிறத நம்ம தெரிஞ்சுக்க முடியும். Already we know well mass and weight. That is, the mass of an object is the quantity of matter. The weight of an object is the force with which it is attracted towards the center of the earth. Here SI unit mass kilogram, SI unit of weight is Newton. Here the mass of an object is constant, the weight of an object is not constant. The mass of an object can be never zero. Here the mass of an object can be zero. Yes, so G is equal to 0. G means gravity. Okay, thank you students.